So we've been discussing the nitrogen oxides and sulfur oxide emissions that occur and how that contributes to acid rain. Well, most of the sources, if not all the sources, man-made, stem from the reliance on fossil fuels. So this graphic represents the percentage of use of major forms of energy. And a timeline is on the x-axis with the percentage of usage on the y-axis. So from the 1850s through the 1900s, we relied heavily on coal as our primary source, about 80% reliance on coal for electrical generation and maybe even heat. So coal became really popular and heavily used once the railroad started in the United States and it became more common. Then in the 1900s we started to see more use of petroleum and oil, and this became a greater demand and necessity for using with the growth of our use of automobiles. So, some of our first cars came out in the 1900s early on, and so this area shaded in brown basically demonstrates our reliance on oil for gasoline. Natural gas became more broadly used after World War II, after the 1940s time frame. And then nuclear is this dark blue color. It's a more recent invention that has only increased in recent times, despite some of our problems in dealing with the waste. And then the aqua blue here depicts our reliance on hydroelectric power and then other renewables. So understand that we primarily rely on these three brown areas. So about 90% of our electric generation and energy consumption is originating from the use of fossil fuels, being coal, petroleum and oil, and natural gas. This is a diagram depicting the total energy consumption in China based on the type of energy consumption from 2011. So it looks like China relies heavily on coal, with about 70% of its energy consumption coming from the burning of coal. Then 18% is from oil, and 4% is natural gas. So if we add those together, 18 plus 4 is 22%, and adding the 22% onto the 69, we're dealing with about 90% of the energy consumption in China is based on fossil fuels. And then you have a small percentage, 6% on hydroelectric power, less than 1% on nuclear, and less than 1% on other renewables. So again, we have another country that is heavily reliant on fossil fuels. And then this lists the carbon dioxide emissions from 2013. Their total emissions are depicted on this side of the bar chart, and the per person emissions is depicted on this side of the bar chart. So it looks like total emissions are highest in China and in the US, and then the European Union consists of 28 countries. So if we were to go country by country, like Germany or France, if they're listed here, France is listed here, this would be a smaller bar chart. So really the top three CO2 producers are China, United States, and India. From a per capita standpoint, on a per person basis, the United Arab Emirates have the highest CO2 emissions on a per person basis, followed by Australia, and then followed by the United States. So how does acid rain form? Well, the sulfur dioxide reacts with water vapor and creates sulfuric acid in the form of H2SO4 and sulfate salts. Sulfur dioxide is a colorless gas with a distinct odor, and 1/3 of our sulfur dioxide is coming from natural sources, such as active volcanoes, and 2/3 of our sulfur dioxide in the atmosphere is coming from industrial facilities, oil refining, and other human sources. Nitric oxide, a colorless gas, forms when nitrogen and oxygen react under high combustion temperatures. Automobile engines and coal-burning power plants, as well as industrial facilities, emit nitrogen oxide into the atmosphere. What happens is it combines with oxygen and then turns into nitrogen dioxide, or NO2. The nitrogen dioxide and the nitrogen oxide combined are collectively called NOx, NOx. These react with water vapor and then create what's called nitric acid, or HNO3. The nitric acid and the sulfuric acid then fall out during precipitation events as acid rain. I would also like to point out that nitrogen oxides can cause respiratory problems and affect the growth of vegetation and reduce visibility. They are also components of what is called photochemical smog and photochemical oxidants, which can cause lung damage as well. This is a map, two maps depicting the pH concentration in rainfall in the United States at different time frames. The bottom left corner represents 1999. The top right is 10 years later and represents the year 2009. There is an evident increase in pH in certain areas in the United States that's depicted by this orangish reddish color, having a pH of less than 4.3. It's in a red color, and the orange colors indicate acidic rainfall in nature. So neutral is a level of 7 on the pH scale, so anything less than 7 is considered acidic. And we're seeing values of acid rain in the range of 4.2, 4.3, 4.4. Notice that the acid rain area is larger in 1999 compared to 2009. A main reason for this difference is that we passed the Clean Air Act and amended it in 1990, and those policy changes were implemented, and it caused a reduction in what was being emitted into the atmosphere by many of our point sources of nitrogen oxide and sulfur oxide emissions. So at the top of the screen you have CAIR, C-A-I-R. This stands for the Clean Air Interstate Rule that was passed. And this has helped reduce Pennsylvania emissions. It looks like our sulfur dioxide emissions are listed in this part of the chart, and our nitrogen oxide emissions are listed in this part of the chart. So between 2003 to 2015, we've definitely have seen a reduction in sulfur dioxide emissions. Actually, we'll look from 2010 to 2015 because we didn't have any data here in 2003. So we went from 235 tons to 132 tons. Overall, in Pennsylvania, the sources reduced the emissions of sulfur dioxide by 86%, which is a good percentage of reduction. The nitrogen oxide emissions have actually been reduced by 56% since 2003. So again, we're seeing improvements in the amount of nitrogen oxides and sulfur oxide emissions into the atmosphere. So projected improvements in air emissions that travel across state boundaries have occurred, and we've reduced the emissions from sources in Pennsylvania, including fine particle pollution as well as ground level ozone pollution. Currently, Pennsylvania sources do still contribute to fine particle pollution in the District of Columbia and our neighboring states such as Maryland and West Virginia, North Carolina, New York, New Jersey. In 2011, CAIR was replaced by another ruling called the Cross-State Air Pollution Rule, so that we can now address cross-state air pollution that impacts other states as well. So there's a couple things that we've implemented with some of these laws that have been passed with the Clean Air Act and the CAIR program and now the Cross-State Air Pollution Rule. One thing is called continuous emissions monitors, or CEMs, continuous emission monitors. Basically, each industrial facility or power plant must have computer systems in place that measure the amount of nitrogen oxides or sulfur oxides that are being emitted into the atmosphere. So basically, a sample of the gas that's being emitted through the plant smokestack is taken and analyzed, and we measure what the nitrogen oxide emissions are as well as the sulfur oxide emissions. And this basically is also reported live to the state regulatory agencies. So any of the state regulatory agencies' staff can check to see what a particular facility is doing at any time of day. Another practice that's been implemented is the cap and trade program. And basically, we work with industries that have a set permit level, and 1 ton of sulfur dioxide emissions released from the plant smokestack might be what the allowance is. And they're only allowed to release that amount of SO2 equal to that allowance that they've been issued. If the plant expects to release more sulfur dioxide than it has allowances for, it has to purchase more allowances from another facility that is beneath their set level, or it could install technology to decrease their emissions at their facility. So a plant can buy allowances from another power plant that has allowances available in order to cover what its emissions are. So cap and trade is one approach that we're doing. There's some benefits to it. There's also some disadvantages to it. Some people use the phrase that it's, kind of a permit to pollute. Basically, you're paying off the rights to pollute and not upgrade your facility to meet air quality requirements. So let's go on to the next slide. Some other solutions are listed on this slide, and in terms of being able to reduce nitrogen oxides and sulfur oxides, putting in good cleaning technology to remove sulfur dioxides and nitrogen dioxides from air emissions from industrial facilities. Removing old, less efficient power plants from production and replacing them with new technology would be a benefit. Increasing vehicle emission standards so that we have better fuel efficiency with the gas that we're burning. And continuing the CEM systems for real-time monitoring of what's going on with the factories. I mentioned the cap and trade program as well. So, wrapping up our Chapter 3 on ecosystems, we basically have covered aspects of geochemical cycling, the carbon cycle, the sulfur cycle, the phosphorus cycle, and the nitrogen cycle, and the human impacts related to those individual cycles. So, we do need to learn more about the health of our ecosystems around the world, and in 2005, an ecosystem assessment was conducted, and it shows that we need more baseline ecological data in order to evaluate the status of the world's ecosystems, in order to develop effective technologies for preventing and slowing ecosystem degradation, and in order to identify boundaries that lead to irreversible changes if we pass these boundaries. So, for example, what is the maximum level of carbon dioxide that we can have in the atmosphere before we hit what's known as a tipping point, where we can't go back, basically. So there is need for further study in regards to ecosystem health. And then the 3 big ideas from this chapter, again, just to reiterate, is that the life in an ecosystem is sustained by the flow of energy and the cycling of nutrients through that ecosystem. Also, every ecosystem has producers, consumers, and decomposers, and they all aid in the cycling of nutrients. And then finally, human activities are impacting the geochemical cycling of nitrogen, sulfur, carbon, and phosphorus, and sometimes this could be negative impact on the environment as well.